Friends, I will now discuss with you about some of the important technologies, material, equipment, and the higher performance levels that we expect in a modern fighter jet, taking both the present and future requirements into account. And this is just based on my information and my thinking. So any minor omissions, you are most welcome to suggest, correct, and update. So what we expect in a modern fighter aircraft are that the aircraft should have the stealth characteristic features. There should be extensive use of advanced aerospace components. It should be of the fourth plus or the fifth generation. It should have highly advanced electronic warfare systems. It should be equipped with the ASR radar, the Advanced Electronically Scanned Array Radar, and the IRST system, that is the Infrared Search and Track system. The aircraft should have good BVR missiles, the Beyond Visual Range missiles. It should be highly maneuverable so that it can intercept the missiles. It should have good friend or foe system, IFF system, so that there is no confusion. And it should have proper radar absorbent materials so that its radar cross section is reduced. It should have good avionics so that the pilot can operate the aircraft at its full efficiency. And last but not the least, the aircraft should be cost effective also. So when we talk of stealth aircraft, the fighter aircrafts that are now being developed are being developed with the stealth characteristics. So this means the aircraft should have a very low radar cross section. This stealth characteristic feature, it is achieved by reducing the amount of radar signal power, which is reflected back from the stealth aircraft to the transmitting radar. And there are two ways of doing it, reducing the reflected energy. Either absorb the radar signal fully or say substantially, or deflect it away from the direction of the radar transmitter. So the special radar absorbent materials, they are used in the stealth aircraft. The shape and contours of the aircraft greatly influence the effective radar cross section. See, a concave surface or a plane surface, it tends to reflect the radar waves back to the transmitter in the same direction of its arrival. So this is to be avoided. The examples of concave surfaces are the engine inlets, the right angles where the wings join the fuselage, the open bomb base, and even the cockpit, if the windscreens are transparent to the radar signals. So the convex surfaces, on the other hand, they tend to scatter the radar waves in widely scattered directions, reducing the amount of energy reflected back to the source. And some of the smaller features, smaller structures should also be geometrically designed to reflect the impinging radar signals in a different direction. And the aircraft should also deploy the advanced aerospace composites. This is to facilitate a lighter weight, good maneuverability, higher operating temperatures, greater stiffness, higher reliability, the increased affordability, good radio frequency, compatibility of the fiberglass radomes, and low observability of the airframes for this stealth aircraft. See, this can be achieved only with the composites. The high performance composites are developed because no single homogeneous structural material, it can be found meeting all the desired attributes for a given application. So the fiber reinforced composites, they are also developed in order to achieve the improved performance. See, the aluminum alloys, which provide high strength and fairly high stiffness at low weight, they have provided good performance and they have been the main materials used in the aircraft structures over many years. But the corrosion and the fatigue in aluminum alloys, they have produced problems which have been very costly to overcome. And the fiber reinforced composites, they enhance the performance and reduce the maintenance costs also. So now let's see something about the electronic warfare. The electronic warfare technology, it refers to the use of electromagnetic waves to sense, to detect, to locate, track and communicate with the systems on air, land or water. The electronic warfare technology is the use of electronic sensors, communication systems, the electronic countermeasures to disrupt the enemy systems, safeguard the friendly forces, and gain a tactical advantage over the situation. See, the electronic warfare solutions cover a wide range of products, services, and strategies designed to address the specific electronic warfare challenges. So these electronic warfare systems, they require the deployment of the cutting-edge technology and expertise to enhance the situational awareness, operational effectiveness, and the mission success in complex electromagnetic environments. It addresses mainly the designing of the electronic warfare systems working in both the VHF and UHF bands, that is very high frequency and the ultra high frequency bands, and the multiprocessor application architecture and designs, the high-speed digital and the mixed acquisition hardware designs, the designing of the good radar controllers and the data processing systems, the FPGA, DSP, GPU-based signal processing systems. So the field programmable gate arrays, the FPGAs, they are an increasingly popular technology for implementing the digital signal processing systems, the DSP systems. And again, it also addresses the ensuring of signal integrity, power integrity, thermal analysis for the signal processing systems, and also the RTL coding, that is the register transfer level coding in VHDL, that is in the Verilog hardware description language and the high-level synthesis. Then comes the use of ASR radar and the IRS track systems. See, then what is the purpose of this? The modern fighter aircraft using active electronically scanned array fire control radars, they are able to detect and track the targets at long ranges in the order of some 50 nautical miles or more. So low observable or stealth technology has contested today the radar capabilities, reducing the tracking ranges roughly to 1/3 or even less for the fighter aircraft radars. And therefore, the infrared search and the track system, IRST systems, they have been considered as an alternative to the radar. And BVR, the beyond visual range missiles, what is the goal of this? See, air-to-air combat is to kill the enemy at long range before he can harm you. But for that purpose, we need beyond visual range missiles and the beyond visual range air-to-air missiles, BB-RAM. They are long-range missiles used by the fighters to knock out the enemy fighters, bombers, tankers, the drones and other aircraft from ranges beyond a particular distance, beyond some 37 kilometers or so. So one major issue with the BVR is still unreliable IFF technology. See, this IFF, it is a secure aircraft identification system which detects and tells us the difference between the friendly and the hostile aircrafts. So these systems use the electromagnetic and the radio frequency devices to communicate with the aircrafts and identifying the friendly, foe or neutral forces in the airspace in military operations. The equipment acts as a sophisticated digital version of a challenge and response password system, sending out a challenge signal and checking whether it receives a correct password. So on IFF system, it is a two-channel system using the interrogating signals and the response signals, of course, in different bandwidths. Now let us see the importance of avionics in a fighter aircraft, especially in a modern fighter aircraft. See, avionics is a combination of two terms, the aviation and the electronics. So in simple terms, it is the electronic systems used in the aircraft, which includes the flight control systems, the engine controls, flight recorders, the communication systems, which are most essential components of the avionics, which connects pilots to the ground crew and authorities, and the navigation systems like the GPS for mine navigation and radio systems in case of emergencies. The threat detection systems, weather systems like the weather radar. So this warns the pilots about the excessive precipitation, turbulence and other harsh weather conditions, thereby enabling the pilots to adjust the aircraft's altitude to keep a safe flight path. So nowadays even you can access the affordable weather systems for light aircraft that can detect the lightning, storm activities, etc. And monitoring systems, which include the gauzes, dials, and other similar instruments involved in a more computer-based technology instead of manual models, which we find in older aircraft. Then the fuel system. See, every aircraft needs fuel system that calculates the remaining fuel and manage the other related tasks to ensure the efficient fuel usage. So running out of fuel, it may create disaster in the aircrafts. Then comes the collision avoidance and the traffic alert systems. So this technology, it detects the other aircraft and alerts the pilots about the possible collisions. It comes with software which provides the instructions after seeing the potential accidents and the ground proximity warning systems for the additional safety. And the flight control, it was initially used in the bomber planes to keep them steady during an air raid. But in later years, it evolved to prevent the pilot error, especially during the landing and takeoff. See, today it is considered one of the most critical avionic systems, the flight control systems. The more complex the aircraft is, the more sophisticated the electronic system it needs. So additionally, the most advanced avionic systems integrate the multiple functions to simplify the maintenance, improve the performance, and also reduce the cost. Then what is the role of super maneuverability of the fighters? What are the advantages of it? See, there are a number of special requirements for the modern fighter aircraft, including the latest fifth generation vehicles. So one of them is maneuverability and the controllability. Say the cockpit of super maneuverability, the concept of the super maneuverability of the fighter, it began to take shape in the 70s of the last century. The existing fighters of that time had certain restrictions on the maneuvering which could interfere with the effective air combat. So a maneuver with access to the critical angles of attack, depending on the type of aircraft, it led to the dramatic change in the nature of the flow, stalling and stalling into a spin. So at the same time, the increase in the flight speeds and the improvement in the armaments, they warranted the need for further improvement in the maneuverability of the fighters. See, this super maneuverability is useful especially in close combat. The angular velocity of a passing target, it may be high, which places the special demands on the maneuverability of an attacking aircraft. So he must have time to turn on the target to perform a successful attack. Similarly, the situation is with the similar is the situation with the defense aircraft also. A highly maneuverable aircraft will be able to twist the enemy, get out of the blow, and even counterattack. So in long-range missile combat, the super maneuverability can be used to increase the effectiveness of an anti-missile maneuver. In certain conditions, some typical aerobatic maneuvers, it can be used to counter enemy radar systems. And there are many aerodynamic issues which will have to be addressed to obtain super maneuverability, like the special airframe structures and the aerodynamic controls are also required. In fact, the aircraft should be able to easily and quickly enter into the supercritical flight modes. See, even the engines, depending on their design, they provide control over all channels. In the context of super maneuverability, it is necessary to consider not only the thrust vector control, but also the main parameters of the engine. So the exit or say the switchover to the supercritical modes when performing some aerobatic maneuvers, it can lead to a sharp loss of speed. So in order not to be at a disadvantage in such a situation, the aircraft must be able to quickly pick up the speed, and to do this, it requires a very powerful plant of sufficient power, engine of sufficient power. So now with this we will switch over to the classification criteria, the generational classification. See the exact list of capabilities and the aircraft belonging to a particular generation, it is always debatable. The classification refers only to the jet-powered fighter. Use of the generations, it helps to demarcate the technological advances and the capabilities. See, the generational classification of the jet fighters, it is primarily based on the major improvements in the performance of the jet fighter aircrafts. In the areas of course, aircraft design, avionics, and the weapon systems. So the term generation, it first appeared in the 1990s. The generation is said to have occurred or changed when technological innovation cannot be incorporated into the existing aircraft through upgrade or retrofit. Then we say there is a change in the generation in the technology. So classifying the aircrafts into different generations, it depends more on the professional approach, the experience and judgment. See, I therefore may or may not be 100% correct in doing this. However, more generally, the first generation jet fighters are the earliest jet fighters. They were subsonic, armed with the machine guns, the autocannons for air-to-air combat, having limited electronics. So the most common examples for the first generation aircraft is the Korean war vintage US F-86 Sabre and the Soviet MiG-15 Fagot. So the hallmark of the Generation 1 fighter, it was its revolutionary advance in speed over its piston engine predecessors. The second generation jet aircrafts, they were supersonic with limited onboard radar capability. And they were armed with early air-to-air missiles like the AIM-9 Sidewinder, the Soviet MiG-17 and the US F-100 Super Sabre are identified with this generation. This generation, it sought to maximize the fighter performance by tailoring the airframe to the potential of the jet engine, like the use of highly swept engines. And coming to the third generation fighter aircraft, the first serious attempts at multi-role capability, it came to be classified as the third generation fighter aircrafts like the United States F-4 Phantom II and Soviet MiG-23, the Flogger, equipped with the beyond visual range missiles. So they featured advanced missiles, supersonic speed and more sophisticated engines. The F-4 Phantom was a late generation 3 fighter and perhaps it is the iconic of this group. And the fourth generation, it saw a quantum jump in the technology related to all the three parameters like the avionics, weapon systems and the aircraft design, resulting in high maneuverability and the look-down, shoot-down missiles capability. So these fighters, they are developed in the mid-1970s and they are still the tops in most of the countries. So this group, it includes USA's F-15, F-16, Russia's the Su-27, MiG-29 and its offshoots. And further improvements in these areas in the same category of the aircrafts for the next 30 years, they have pushed some fighters into a group known as the Generation 4.5. So these include the latest F-15s and the F-16s and even the MiG-35, Su-30 and the Eurofighter Typhoon. See, the fifth generation jet fighters, they are the most advanced jet fighters as of today. The fifth generation, they are designed to incorporate the numerous technological advances over the fourth generation jet fighters, and stealth being one of the outstanding features. This class is stealth in all aspects, It provides for the internal carriage of precision weapons, active electronically scanned array radars, and the plug-and-play electronics. See, while most of the fighter aircrafts operating with the advanced militaries across the world, they are the fourth generation or the fourth generation plus. Very few fifth generation aircrafts are in operations presently. And as per reports, the only combat-ready fifth generation fighters, they are the Lockheed Martin's F-22 Raptor, which entered service with the United States Air Force in 2005, and the Lockheed Martin's F-35 Lightning II, which entered service in 2015, and the Chengdu J-20, which entered service with the Chinese Air Force, called the People's Liberation Army Air Force, PSAAF, in September 2017, which are claimed to be the fifth generation aircrafts. They are, I think, not yet combat tested, and seems they have some issues regarding their performance, despite the claims to the contrary by the manufacturers. And I think the other aircrafts like the Shenyang J-31, the Sukhoi Su-57, they are in the final stages of testing and operational clearance. These are also the fifth generation aircraft. And the India's advanced medium combat aircraft AMCA, which is being designed and developed by the Aeronautical Development Agency ADA, is also a fifth generation fighter aircraft, and the same will be produced maybe in another 3 to 4 years. And coming to the sixth generation, see, this class is on the drawing board yet and may not be available for another few decades. And this would perhaps feature, means it will come up with the hypersonic speed, the dual mode engines, and the adaptive shapes with optionally manned and directed energy weapons capability. So friends, with this I will close my discussion. Thank you very much.